Hello and welcome to this video presentation for the 2019 Global Analytics Competition. My name is Paul. I'm a Master of Business Analytics student at Deakin University. I'll be making this presentation on behalf of my two fellow teammates, Harpreet and Musa. The issue we've chosen to investigate is the use of hydraulic fracturing, also known as fracking, in Australia. In Australia, fracking has had a controversial history. It's currently banned in Victoria, heavily regulated in New South Wales, and moratoriums exist in both Tasmania and Western Australia. The federal government broadly supports expanding the use of fracking, with former Prime Minister Malcolm Turnbull supporting opening development in Northern Territory, and the Energy Minister has recently stated that fracking can play a large role in securing Australia's future electricity needs. There have been a number of recent developments highlighting a potential increase in the use of the technique. There are a number of developments that are approved in exploration in Queensland, with production expected to come on board in late 2019-2020. In April 2018, the Northern Territory government lifted its ban, allowing fracking in over half of its land mass. Western Australia in December 2018 have also opened up fracking in 2% of their state, or an area of 5 million hectares. Those in favour point to a potential economic boom and the positive economic outcomes that have been seen in the USA. The opponents, however, point to a variety of studies from scientists and media reports outlining a range of potential environmental impacts, including impacts to water quality, water availability, consequences for agriculture, higher air pollution, and a higher risk of earthquakes. In this presentation, we will review a series of dashboards created to investigate the potential increase in the use of fracking in Australia. So firstly, what is fracking? So really briefly, it's a technique used to access what's known as unconventional oil and gas reserves, such as shale gas and coal seam gas. It uses a high volume of water and a series of chemicals that often have a proprietary formula. As a byproduct, there's a high amount of wastewater that's produced that must then be disposed of. So we managed to source a large amount of data from a variety of reputable sources, including BP for global energy use data, and then a variety of US government agency sources for state and county level environmental data to be used for analysis. So a lot of our time and effort was devoted into defining the problem that our user, the Australian government, or any interested Australian stakeholders would have. And so to do that, we kind of divided the problem into a series of hypotheses that we wanted to test. Firstly, the positive side of the ledger on the potential reduction in emissions by using a higher amount of gas in electricity production, and then a series of different potential negative consequences. And to do that, we wanted to firstly take an overview at a state level with the American data that we had, and see, broadly speaking, were there any issues highlighted in those states that have increased the use of fracking, and then secondly, dive deeper into a more granular level and see whether we could detect a correlation specifically between the areas where fracking was undertaken and then any negative consequences that may have resulted. I chose to use Microsoft's Power BI to develop our solutions, and a lot of our effort also went into firstly cleaning and then aligning all of these data sets together to be able to be suitable for use in our presentation. So we're going to do a demo now of our first dashboard in Power BI. That one's just using the BP global energy data, and it's just testing that hypothesis that increasing the percentage of gas used in the electricity production process has a net benefit in lowering CO2 emissions. Firstly, we've defined a metric here, which is emissions efficiency. That's just the total CO2 emissions divided by total electricity production. It's just a way of normalizing for the size of the country, so it takes into account the total electricity produced. It just takes a look at the overall efficiency of that production process for the country. So we can see firstly, filtering on the United States, that their proportion of gas used in the production of electricity has consistently come up since 2007, and the proportion of coal being used has gone down, and that emissions efficiency has continued to improve, and also there's been a net reduction in the total CO2 emissions. Now, filtering on Australia and taking a quick look in contrast, we can see that whilst the total percentage of gas as a proportion of that electricity production's gone up slightly, and the emissions efficiency has initially began to improve, it's kind of plateaued around that 1.5, 1.6 mark, and so have the total CO2 emissions. And our usage of coal has come down slightly, but is still relatively high. Moving on to the next dashboard, which is on total gas production and consumption. This one just is really brief, and just filtering on Australia here, we can see that the total gas production has continued to increase, and the consumption, however, has increased but plateauing. Australia is a net exporter of gas. So the key insights from that global exploration through those dashboards is that hypothesis originally, that increasing the proportion of gas in the electricity production process would have a net benefit to lowering carbon emissions, has been proven. Both the United States and the United Kingdom were able to achieve that. But it's not the only way. So the number of countries have also reduced it through increasing the reliance on renewable energy sources. Those include Italy and Germany, as well as the Ukraine. And then there's the United Kingdom, which did it through both increasing gas and increasing the amount of renewables. That second dashboard shows that Australia is a net exporter of gas. So, in brief summary, increasing the amount of gas used in electricity can have a benefit in lowering CO2 emissions. It's not the only way. You can do it through renewables as well. Australia currently has an excess of gas that's being exported, so that gas is available. It doesn't necessarily follow that we need to use fracking to achieve that increase in percentage of gas in the production of electricity. Next up, we have the first of our dashboards for the potential negative consequences of fracking. This one is a animated overview of air quality from the time that fracking begins. You see we've defined three main metrics using the air quality data we have available, and those are the percentage of unhealthy days defined in the air quality index, the percentage of days above the particulate matter emission standard, and the percentage of days above the ozone emissions standard. In this dashboard, we use animation. At the top right hand corner, you see a button where we can play and see the changes over time in these particular geographic maps, and we do that in most of these overviews to represent the changes. We're interested in the change over time, but we're also interested in the geography of where the gas production is occurring, so we can see these occurring at the same time. So next we'll move on and demonstrate this animation in practice for the first metric in unhealthy days. Following on from this, we have the exploration dashboard for air quality. This is designed to look at a county level to look specifically at locations where fracking wells exist. So here we have filters to select a state, which then zooms this map in the top left hand corner in to view where each county is shaded according to the number of wells that exist there, which will then enable the user to select a county and have the dashboard update accordingly. We have the ability to view each of these metrics: particulate matter, ozone emissions, sulfur dioxide or nitrous oxide emissions. Currently we're filtered on New Mexico, and at a brief high level we can see for the metric we're currently selected, which is ozone, that once fracking uptakes around 2009-2010, there's a clear increase in ozone emissions in the state. We can filter in and drill in further and have a look at the specific counties and see if we can attribute a direct correlation from there. So utilising these dashboards, the key insights into air quality and fracking that we were able to uncover are as follows. So using the first dashboard and the state level overview, first insight is that the percentage of unhealthy days appears to have no correlation with the level of shale gas production. There's some increase initially in Oklahoma, but since subsided, and in other states there is a net reduction regardless of whether it's fracking or non-fracking. In terms of particulate matter, there are some states at a high level that showed some increases, but it wasn't uniform across all fracking states, and it wasn't necessarily more or less than states that were not embarking on fracking. However, the strongest impact appeared to be with the level of ozone emissions, with most states that had high levels of fracking experiencing an increase in overall ozone emissions. This was particularly evident in West Virginia, Ohio, Wyoming, Texas and Arkansas, amongst others. Moving on to the local level exploration, showed a much different story in terms of particulate matter emissions, looking specifically at a number of counties that had high numbers of wells, and utilising the explain this increased feature of Power BI was able to help with uncovering some of these. In Ohio, Trumbull, Allen and Lorain all showed significant increases and all had high numbers of fracking wells, and Lorain particularly over 2,000 wells. In North Dakota, McKenzie County, which had over 3,000 wells, showed substantial increases. In Pennsylvania, there was a cluster of counties around Westmoreland which has high incidence of fracking, which showed substantial increases. And then looking into ozone also showed similar correlations. Menongolia, Hancock in West Virginia, and a number of different locations in Arkansas, Ohio and Wyoming. So there was that first initial overview, slightly misleading, showed less correlation at a state level as can be expected, and then when you dug into the county level, locations that had high numbers of wells did indicate signs that the air quality was deteriorating. Next we have two dashboards looking into earthquakes. Following similar to air quality, we have a animated view by state, and this time we have shale gas production, number of wells, and number of injection wells as the three options to take a look at. We also have a local level view, and just in the interests of time, we'll only demonstrate the animated view here. The analysis into earthquakes is really dominated by Oklahoma, which saw a really significant increase in the number of earthquakes, and is strongly correlated with locations of wells, but particularly with locations of injection disposal wells. Outside of the Oklahoma trend, some other states also saw increases, not as significant as Oklahoma, which went from minimal to well over 2,000 a year, but nonetheless tripling from 50, 100 up to 400, 500 earthquakes a year. This is seen in states like Texas, Arkansas, and Kansas, all of which are closely bordered to Oklahoma, so could be on the same fault lines. The Pennsylvania cluster of gas-producing states further north didn't see the same trend, so it kind of indicates whatever is causing this phenomena, it's not a direct link necessarily with fracking. It is potentially more complicated, and further research might be needed into it. The high amount of water needed for fracking places a potential threat on agricultural production. We follow the same approach as the prior dashboards, again looking at a state level animated view to look at the high level trends, and then secondly looking into a local level county exploration dashboard to dive deeper into what's specifically happening in locations where wells exist. Here we took a look at two of the main crops produced in America, corn and rice, and we also looked at cattle inventory. And again, we're just going to quickly demonstrate only the animated overview and not the exploration dashboard here, and then dive into the what we're able to uncover in our analysis. The main insights uncovered in our analysis into agriculture surrounded rice and cattle. Corn saw a small drop in Ohio, but nothing major. For rice, not as many states produce rice, but Arkansas is a fracking state and also the largest rice producer, and it did show a drop in rice production, and also particularly when you looked at the number of acres planted, which showed a potential land use issue occurring with the increase in fracking. Cattle inventory nationally dropped sharply, but it correlated at the same time as a drought that impacted the Texas region. So not necessarily a direct result of fracking, but the high level of water use required by gas fracking, which is quite large in the Texas region, can't have helped at the same time. Looking at a local level showed some more interesting correlations at particular counties, particularly ones where the cattle inventory dropped to zero during times when fracking was undertaken, and came back up once the fracking was ceased. So definitely there are some indications that increasing fracking and the water use and land use required does pose some potential threats to agriculture that need to be managed. The last potential issue that we looked into was gas pipeline spills. Gas pipelines are used throughout the production and distribution process, as you can see below in the flowchart. We focused particularly on the production, gathering and transmission stage rather than the distribution to end customers. Quickly demonstrate the dashboard we produced for this. The analysis really demonstrated that pipeline spills are low frequency but high potential impact, both in terms of property damage and potential loss to life and injury. The number of pipeline spills didn't increase majorly across the time period, but did increase particularly around 2014 to 2016. As a result of our analysis, we have a number of recommendations we'd like to make to conclude this presentation. The first is that Australia should explore redirecting existing gas production domestically before beginning to grant fracking licences. Australia should explore limited expansion of fracking as one component of an integrated energy policy, including a concurrent increase in investment in renewable energy similar to what was achieved in the United Kingdom. An economic and land use studies should be conducted prior to any expansion in fracking, which would enable any risks to agriculture and pipeline threats to be managed. Fracking licences should not be permitted in areas where existing water availability is already an issue, including the Murray-Darling region, and any licences that are allowed should be accompanied by a water study and an appropriate disposal plan that is monitored strictly. Farming areas currently used for livestock, such as cattle, should be restricted from fracking licences due to the high risk of potential contamination. Strict guidelines and standards on allowable chemicals in the process should be designed and strictly enforced. Any fracking licences should be rolled out gradually, with strict air pollution monitoring targets adhered to. Thank you for listening to this presentation.